All right, car crash example. Cars in the 1950s were made out of solid steel so that they bounced off each other when they collided. Cars today are built out of plastic materials that crumple when they collide. The speed limits during both the time periods were about the same, and people during both time periods had about the same mass, on average. During which time period were injuries from accidents worse? Answer the question and explain your reasoning in a well-organized paragraph. If you are asked to explain your reasoning or justify, there's a way to answer these questions to make sure you get all of the points. You are familiar with this with a lot of your other science classes, and that is the CLR method. Right? CER, sorry. I don't know why I said L. So we have C, which is the claim. What is your answer to the question? The question is, during which time period were injuries worse? Claim, injuries were worse in the 1950s. Stick with me through the writing of this. I'm sorry it takes forever. Injuries were worse in the 50s. You had more deaths. Injuries were worse in the 1950s. That's why the cars changed. That's why we went from having this rigid body colliding and then bouncing back to having something with a crumple zone that will help absorb some of the impact, so they kind of stick together a little bit. What that does is it obviously increases the contact time for the collision, which is going to decrease the amount of force, as we've seen in previous examples. So what evidence do we have? The evidence part, that's what the E is, evidence. Evidence for this would be an equation of physics thought. And for this one, as I was just explaining to you, I used impulse momentum theorem. So I would say m delta v equals f delta t. Right? There's my evidence. Now what is my R? R is the reasoning. If you have reasoning, if you haven't learned this in your other science classes and you go on to other science classes outside of physics, use it there. And you'll see that you're going to get better scores on your free response question. You no longer have to think, what the heck is this teacher even asking me? Just make your claim, provide your evidence, and use your logic mixed in with your, in this case, physics terms and vocabulary to give a nice reasoning, nice explanation of what's going on. So if we have the cars in the 50s were crashing and going backwards, then that means there's a greater change in velocity, right? Because you're going from positive to opposite. So it's a bigger change. Instead of just going from positive to 0, you would have to have a greater force to send it backwards. Greater change in velocity. With bouncing, which is a word used from the question, they bounced off each other, means more force. Let's say you're sitting on the AP exam and you somehow miraculously spewed this onto your piece of paper. Are you going to worry that it's not in complete sentences? No. Who cares? Greater delta V with bouncing means more F. Somebody who knows physics a little bit knows exactly what you're talking about. But then you have to bring it all around. You have to put it all together. So more force means more injuries. Don't forget to bring it back home. Back to the answer means more injuries. One day I will get a good working pen. Now we've got this checklist here. Is this checklist going to be given to you on the AP exam? Absolutely not. But here it is, just to work with us while we're learning how to do this. Did we answer the question directly? Yes, that's our claim. Absolutely. Did we state a law of physics that is always true? There's our evidence. Yes. Did I connect the laws of physics to the specific circumstance? Yes, we're talking about bouncing, meaning more force. Even if you wanted to take a little F and just draw one of these little guys in the air, so you know, okay. Or maybe you want to do it for velocity. Just make sure it's communicated nicely and neatly. Don't have arrows everywhere. Yes, so we did that. Did we compare the two situations? State what was the same in both cases. Ooh, we probably could have done a better job of that. So we could say less force now means less injuries. Less injuries. And I'm going to pretend like I wrote it behind my face. I contrasted the two situations, stated what was different. Yeah, I think we're covered there, now that we fixed it. Did we use physics vocabulary? Momentum, mass, force, velocity? We did, but we used symbols, but guess what? That's okay.